So, hello, my name is Sergey Kuznetsov. I have been asked to run some live streaming coding session about Elixir for Exercism.org in frames of functional February. And I hope that you hear me well. So let me introduce a little bit more myself. My name is Sergey Kuznetsov. I live and work from Stockholm, Sweden since 2019. I live here with my two cats, wife, and recently I became a father, and I have a 7-week-old son. I work as a software development consultant at Agency 0+X, and I recommend you to visit our website because it's like piece of art. It's not that functional, but it's really, really, really beautiful. A little bit of backstory about myself. I started with PHP 15 plus years ago. I worked a lot with Ruby and JavaScript. And I heard about Elixir in 2017, but I'm not sure. Maybe it was a little bit earlier. But I started to learn it in 2017. And I instantly fell in love with the language. Now I do all my pet projects in this language. And in my free time, when I do not need to help my wife or work on my primary job, I mentor students of Elixir track on exercism.org. I read books on software architecture, software engineering. I really like and I'm in fun and I research and study different agile practices, or I work on my pet projects. So during this stream today, I'm gonna talk about most important aspects of functional programming and Elixir in particular. I'll show you 3 examples of exercises to highlight these topics that I'm going to talk about. And I'll try to do my best to share the love to Elixir and tell you why it is so awesome language. So let's probably start. Let me move my browser here. And also my console. I'm in my workspace. I created some Exercism stream folder. I prefer to work on my local machine. So when I'm solving tasks for Exercism, I, of course, solved many of them. I have not finished Elixir track, so I have not finished 100% of tasks there, but most of them. If I'm not mistaken, let's check how many things I've solved. So I'm almost 75% through the track. Anyway, I also wanted to mention one thing, how I came into functional programming topic in general. Maybe 12 or something like in 2009, 2010, I started to hear about Google and their MapReduce algorithm that helped them back then, of course, to handle terabytes of data. And I was not sure what was that. I learned Scala back to the time, and I even managed to make a little uploader to Hadoop, which is open source implementation of MapReduce algorithm. And, the functional programming, when I started to learn functional programming and Elixir in particular, I started to notice a lot of these methods that we use in our programs in functional programming applications, and they called map and reduce. So we do a lot of mapping and reducing of the linked lists, which is one of the foundational data structure in functional programming in all of the languages. So in Haskell, in Elixir, in many others. For someone who is not in FP yet, a linked list is somewhat looks like an array in other languages, but it's not. Fundamentally, inside, it's very different data structure. Anyway, by the way, the Google MapReduce, why I mentioned it, the naming, it was inspired by the actual map and reduce functions, which are commonly used in functional programming. Although their purpose in the MapReduce framework is not the same. So it's just funny coincidence, funny naming. I wanted to start our little journey here with one exercise. It's quite small. It's called word count. Let me find it here. Word count. And yeah, I solved it a long time ago. And it's going to be just a few lines of code, but it's going to give us some highlights of what Elixir is about. And then we will iterate and touch a little bit more complex topics. So as I told you in the beginning, I prefer to work locally, and it's great that Exercism, they have the CLI application that you can install in Linux or in macOS. Like in my case, you can learn about it here. So Exercism is great about documentation, and it's great about community. And it's already pre-configured on my machine, so I can just download it. It's going to create in my workspace folder the Elixir, which is by track, and also the folder with word count. The only downside that you do not need to do this by yourself, but I need to do that because this CLI tool, it actually downloads your latest iteration that you previously uploaded to Exercism. And I was a little bit too lazy to create a new account and to start from scratch. So I just need to replace my existing code with original source code, which is actually just the blank one. So let me use VS Code and open it, and we'll see. We can start with instructions. So given the phrase, count the occurrences of each word, and it's in italics, in that phrase. For the purposes of this exercise, you can expect that the word will always be one of a number, blah, 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 a simple word, a contraction of two simple words, and some additional things and examples. I prefer to start looking into the tests, which almost always provided by Exercism. And it is basically which helps tremendously in solving tasks. So let's open this and split it in half. So on the right side, we have tests. On the left side, we have actually the file that we need to write code in. And also let me open the terminal just to run one command. We can run tests manually, like mix test. Mix, by the way, is the utility that comes with Elixir installation, and it helps to create projects, configure them, and run different tasks. For people who is from Ruby world, you can think about it like maybe a rake or a little bit similar, but not exactly, because it includes the bundler, the rake, and many other things. Anyway, This will make us to run tests manually after each change. I'm a little bit lazy, and I prefer to automate things. So I'm using this small utility fswatch. I tell this utility to watch for a lib directory and the test directory, and whenever I save the file or I change this directory, it's gonna run this command, mix test, that I showed you before, which I ran manually, and this flag, it helps us to make it a friend with fswatch. So let's see what authors of this exercise wanted. So the first test, let's try to pass it. Let's try to return from this function something. Let's save it. Let's look. Yes, we are green. Okay, let's go to the next. Let's save it. Let's see that we are failing. Now we need really do some work. I propose us to start with some documentation. And regarding Elixir, it's just a great documentation of any language that I have seen previously. So there is website hackdocs.pm /Elixir. Elixir, it's like the name of the package or whatever, because on this website we have lots of documentation for all the packages that are available for Elixir. And here we can pick the language version or whatever, and also check what are the modules available, what are the functions here, etc. I'm not going into details right now. What are the modules? What are the functions? I'm going just to show a quick example here about how to solve this small task in Elixir. To solve it, at first, I need to think, okay, then we need to take the input string and to split it somehow. String, that's some keyword for me. So I'm opening the string module. I can read some great explanations here, or I can go to summary and check what are the functions available. Within some time, you just learn all these modules available, and you just get familiar with the language. So I already know that string module, it has the split function. Here you can read it divides a string into parts based on the pattern. I believe that it's a regex pattern. So let's try to split it. String split, and we will also see what we're gonna have. So string, so we can actually use the regex or just another string here, if I'm not mistaken. Let's see what it does. We can see in the actual output of the task that it was expecting a map, but now we are getting just the list of separated words. So it works somehow. But we need to make a map out of it. To do that, we have the module which helps us to work with maps or with any kind of lists. It's called enum. I'm not going into deep details here, but I can tell you that it actually contains the function that I mentioned before, like map and radius. So enum, it's a go-to module in Elixir, and we do a lot of stuff using this module. Let me make something out of it. So we need enum, we need reduce, and we also need to start when we are reducing some list. We need to start, by the way, list need to go first, I'm sorry. We need to start with something. We can actually omit this starting value, and then the starting value in the first invocation of the function is going to be the first element of the list. But we need to start with empty map. Map, it's like a Ruby hash, or in PHP, I forgot how it's called. I believe that you got the idea. So it's like a key value store of information. It's also one of the go-to data structures in Elixir. Then we also need to tell how we want to reduce the given list. We need to pass the function, and that another interesting aspect of functional programming, that functions here, they are actually can be like arguments to other functions. What is that? And it's not necessary here. Here, let's see what we get here. What is word and what is ec. So let's restart. It's not very useful, but here, for example, we can see that the word was 1 and empty map. Then we got off 1 empty map. Why it looks like that? I'll tell you, because every time this parameter is called as accumulator in the reduction function, and everything that we return from this function, it's gonna be collected or accumulated in this argument. In spec function, it actually returns whatever we passed to it, but we need to change actually these things. So we need to take accumulator, we need to put word in it, and not word, we actually need to create the key in this map, and we need to say that if in the accumulator we already had that key, then we will use it. If we don't have it, we will use null. So let's see what we got here. Now we are passing tests. So we are splitting the line. We are getting the linked lists from it. Then we're reducing this list, starting with empty map, and we eventually put something. So let's see if we can solve with this implementation the next test. Yes, it also gets solved. Let's check the next. Sorry. Okay, now something interesting happens. Now we get these 1, 2, 3 that separated by commas, not by empty line. So we need to do something about that. Before we do that, let me show you one very important, very interesting thing about Elixir language. So in Elixir language, we have the pipe operator. What it does, it does some very nice magic. So this thing is called as pipe operator, and we need to remove this. What it does, it actually takes whatever on the left side of it. We can write it like this to make it maybe more obvious. So it takes whatever on the left side of this operator, and it actually pipes it or moves it as the first argument of the function that on the right side of it. Many people, including me, they prefer to use this pipe operator and put it in the column. And a little bit later, a few minutes later, you will know why. So it's going to be, so right now it's going to run the same. We will also have just one failure just because of the wrong splitting. Yes, because we cannot split it. Because we cannot split it correctly. I propose us to use regex, to start using regex here. And what we have here, regex, we also have the very nice documentation here, different stuff, and we can use regexes with strings or just with regex module. It depends on case to case. I already know, I'm not going to waste a lot of time. I already know that I'm gonna use this lnum thing. Let me check if it passes, if I made my notes correctly. Yes, it passes, and let me tell you why it passes. So lnum character class, it's pointing to letters and digits. And according to our description, we actually need to use numbers and treat them as words, simple words. And if word is split only with one separator, one apostrophe. So this actually reads as split the string, the sentence string, anywhere that is not letter or digit. I know that, by the way, let me show you some additional magic. It's going to be the same code that as before. So we are taking sentence. It goes as the first argument to string split. Then everything that comes out of string split goes to enum radius as the first argument. Okay, let's go and see what is the next test that it's going to fail. Okay, the next, it's going to fail. And why it's failing? Because we are getting the empty string. Okay, let's get rid of empty strings. Let me, by the way, show you one more thing. It's a great thing, IEX. It's called interactive Elixir. And we can play a lot of stuff here. So we can run any of Elixir code here. And sometimes it helps us a lot in quick debugging. So string split here, by the way, if we don't pass any splitter, then it goes with some default. Let's use regex. Not lnum. As you see, after this splitting, we get 1 empty string, 2 empty string, 3 empty string. I know that we have some option to string split that we can pass. It's called trim, and we can tell it, trim please. So it's gonna remove empty strings automatically from it. So let's use it. Trim true. It's gonna run successfully. Then we need to ignore punctuation, but I believe that with lnum it's already doing, yes. It's green. The numbers also should work as expected. Hyphens also goes here. No, hyphens, nope. Nice. So that's great. Then we need to edit here to say that split it. Do not split it on hyphens. So do not split it on letters and numbers, and do not split it on hyphens. Underscores, I believe it goes into elnum. Normalize. That's the interesting thing. So, as you can see, the test was expecting to count us all the goes in the given string in the down case variant, and the stop the same. And we are counting them differently. What I propose to do, that we can down case the whole string, the whole input. So when it comes to the string split, it's going to be already down cased. As you can see, we are green here. Okay, now apostrophes. With apostrophes, I believe that we also need to do it, to add it here. Let's see, yes, that works. Quotations, I believe it works with quotations. Nope, it doesn't. Yes, it was an interesting case that in simple cases it works, but sometimes it also, so we should not split it, or we need to clean up actually all the words. So as you can see, for example, here, let's use it. String split. I need to do this, and then we are taking this regexp and also option. What we get here, we have large in quotations, for example, and it's getting counted incorrectly. What I propose us to do is to use in a map, just to wrap us and to come to this map radius that I started with. Here, I'm doing some magic that you might think of, but let me try to explain it to you. First of all, 1, 2, 3, enum map, function element plus 5, and let's see what it does. So enum map, it goes over linked list, and it runs functions on every given function on every element from that list one by one. What I'm telling to do, and returning the list actually. So here I'm giving it 1, 2, 3, and I'm telling add 5 to any of these elements. Eventually I get this. I can rewrite the same code using the shorthand function. So it's just the synthetic sugar. Sorry, it doesn't does much at all. It's just another way of writing this fn l. So as you can see, I'm using ampersand, then some parentheses, and to tell that I need the first argument and to do something with it, I'm just telling this. So don't care about that. It does the same. And with this ampersand, I can also tell if I want to use any other function. So here in this IEX example, I'm using anonymous function. Here I'm using named function from string module. And I'm telling just remove from the element that I'm giving to you from the list any of apostrophes. Actually trim it. So it's gonna remove all these apostrophes if they're on the left or right side. So this is exactly what we need to achieve. And as you can see, we're already green here. With quotations, it's also gonna be green with substrings at the beginning. Let's see. Yes. Multiple spaces not detected as words. It's gonna work. It's also gonna work, I believe. Quotation. Yes, we solved it. Here, it's gonna fail with UTF symbols because by default, regex doesn't work on Unicode, but it's only by default. It works very well with Unicode, and Elixir works very well with Unicode. We just need to care about it a little bit, at least with regexes. We just need to add one flag to regex, and then it starts to work with German, Polish, and any other even Mercian languages, I believe. So we are passing all the tests. We can submit it. Exercism submit, word count. It even tells us the link that we can open. It's gonna open us that exercise that we just solved. And yes, so this wraps up the very beginning of functional programming talk that I'm going to give today. The next task is list operations. So let me open it here. I chose it because let me start it, and then I'll tell you why I chose it. So, exercism, word count, a list, oops, track Elixir, list, oops, yes, and code Elixir list oops. So in the previous exercise, you have seen how I used enum module and the functions like map and radius from this function from this module. Why I chose a list ops task? Because I think it's great not just to know the libraries that are available to you, to your usage. It's important. It's really important. But it's also very interesting, at least for me, it was interesting to me that how it works internally. So how this map, how this reduce function works, and stuff like that. Let me show you something here. Again, we are starting with the tests on the right and code on the left. And as you can see, authors of this exercise, they are kindly ask us not to cheat, because all of these functions they are asking us to implement, they are already exist in the language and different modules. But it's interesting how we can try to implement them by ourselves. And let's do something. I'll show you during this exercise some of most common patterns that comes to functional programmer brain or mind when you are dealing with functional applications and functional code, because it was interesting thing which I noticed in myself, how my mind got changed and converted to the new paradigm, the functional programming. It's very different from object-oriented programming and what I was doing for many years before. It seems like it's the same, but for example, after learning Elixir, a lot of the things in my head just looks like a linked list, and I'm trying to solve a lot of tasks just by looking from another perspective to that list, to that task. So let's start with count. Count is just supposed to tell us what is the number of elements in the given list. So right now we are gonna have some fail because it's compilation error. If we don't give function a body, then it's gonna fail. I'm not going to go into details how I would solve it, for example, in Ruby or whatever. I'm going to show you something interesting. Let's do like that. So if L in this thing is just the list, if L is empty list, then we should return 0. And it's gonna solve us the first task. Yes, it's gonna be green, but it's gonna fail on the next case. In the case that L is not empty list, we need to do something. And I propose this, and I'm gonna use some recursion here. So I'm gonna use 1 plus. So we are like counting elements in the list, and I'm gonna pass, let me tell you what I'm doing here. So here I'm returning 1 plus count some tail, sorry, not tail, tail. And as you can see, I'm already cheating here. I'm doing it wrong. 1 plus count tail. It should. Now, if L is empty list, 1 plus count tail L. Will fail with argument Elixir. Why it's gonna fail? Let's check the documentation. TL. TL. Yes, it count TL. Let's skip it. Let's not waste our time here. Let me show you some solution here. As I showed you before, if else, that the way I want it to go, it's something that makes me wonder how I lived without it before. 1 plus count tail. Let's check if it works. It should work. So in ordinary languages, in many other languages, let me put it like that, we usually cannot do anything to the arguments we are receiving. For people who is familiar with JavaScript, you probably know about this deconstruction or destruction of arrays or other or objects, etc. It is somewhat similar to this, just to comprehend. But what you're looking here is called in functional programming and in Elixir in particular as multi-clauses functions. So I'm defining, in this particular example, I defined 2 clauses, count and count. They are the same. Both of the functions, they receive just one argument, and they are going to be invoked or run or executed. This version is going to be run when it receives the empty list, and this version is going to be run when it receives non-empty list. And here is the interesting thing happens here. So when it receives non-empty list, we tell that we are not interested in the very first element. We can go, I need to remind that when we are talking about list, it's not an array. In functional programming, most likely, it's in 99% of cases, I believe, if you hear a list, it's going to be a linked list data structure. And linked list data structure is good because we can go item by item. So here we are telling that we are not interested in the first element, but we will need to know the tail, everything that goes after the first element. And what we want to do here, we are telling that we want to return 1 plus and run again the same function with the rest of the stuff. What it's going to do the next iteration, it's going to take tail, and that it's going to be repeated until the list is empty. When it comes to the, for example, if we have a list with just only one element and this goes into this function, then the next tail is going to be just empty list. So this is how it works. Let's try to implement the next thing. By the way, as you can see, I have not used kernel plus, HDTL in this solution. Let's check. Oh, by the way, that's interesting thing I wanted to mention. In Exercism exercises or tasks, some of the tests, they are marked as slow. And it means that they are gonna be slow. So, because they are maybe working on lots of elements. Here is the very interesting example. Let's try to implement reverse in the same way as we just implemented count. Reverse function, it just takes the list, and as you can see here, for example, it takes 1357 and it must return 7531, just in another direction. Let's try to solve it similarly. When we get the empty list, we cannot reverse it. It's already reversed. But now we already interested in the element. Now let me show you what happens here. We need to reverse the rest of and we want to make a new list. Here, by the way, I'm also failing the rules, but I wanted to fail the rules because it's one of the most obvious solutions. But it's gonna work also with this, and even with the next thing. Yes, but it's gonna hang the system. As you can see, it's not gonna end soon on the very long list. Why it is so? Because this instruction plus, it actually adds an element to the rest. So we, for example, we have 1, 2, 3, and we want to concatenate it to another list, like 3, 4, 1. Eventually, it will give us 3, 4, 3, 3, 4, 1. Yes, but this operation is quite expensive. When you are concatenating lists, then every time you do this, virtual machine needs to go over each of these elements from the list on the left side. That it's gonna take a lot of time for million of elements, while we are doing like around 1 million concatenations. So just imagine 1 million in square or something. So it's straightforward. It looks like count, but it's not going to work well for us. We need to introduce something new. And here, let me show you what we are doing. Reverse L. So what just happened? I redefined again reverse function, which receives some list. Then I want to invoke another reverse with 2 arguments. I'm passing the same list as input, and I'm giving the empty list. You will get in a moment what it is about. So I call it, and many other people also call it, as accumulator. For saving time, it's just ec, and you often can find it in the other source code in Elixir or Erlang or whatever. So reverse, tail, head, and ec. What happens? Oh, I need to restart the test. What happens here? By the way, as you can see, even with the huge list, it just took us less than 1/10 of the second. Reverse, no, it's 170 milliseconds or whatever. Not the infinity of time. It's one of the patterns that I told you that I'm going to show you in functional programming that we often need to introduce some accumulators. You already seen it in enum radius function, and here, just to solve the reverse, we also need to solve the performance issues of reverse on the big lists. We need to introduce accumulator. You can ask me how it works. So here, I defined a new function. We can define the function with the same name. We can just change the number of arguments. So in this case, here we see 2 arguments. And we also using multiple clauses functions here. So this helps me just to avoid if else, but probably I can show you the same here. L do, and if L is empty, do if it's empty, then we return an ec. If it's not empty, then we are doing, but I will need to use again HD or whatever. We need to use tail of L, and we also need HD of L and ec. Let's see if it works or not. It works. So basically, this code, it's what you see here, but with multiple clauses functions, it's just much more readable. You don't need to use these nested ifs, else, or something. You just show your compiler what cases you want to support. I want to support the empty list and non-empty list, and I want to have different branches of running. Why it works so performant here, I forgot to mention. Because in the previous implementation, we used the list concatenation. And as I told you, every time it concatenates 2 lists, it must go through all the elements of the list on the left. But we have not the concatenation we can add very easily one element on the left side of the list, so to its head, because we do not need to go through all the elements again. We are just adding. This is the syntax of how we can add. So ek is the list, as you can see, and this is the syntax how we can add one element to the head of the accumulator. Let's go quickly on the other functions. So the map, that's a very nice thing. What map does, as I mentioned previously, the map takes every element from the given list, runs a function on this element, and returns it. Eventually, you get the return value as a list with something happened to the elements in this list. And this is basically what we are going to show here. So again, I want to use multiple clauses here, and I want to start with some basic case. It's another pattern of functional programming and multiple clauses functions. By the way, these multiple clauses functions, they appear in many other functional programming languages like Haskell, Clojure, or whatever. Regarding Clojure, I'm not sure, but I believe so. I start with some basic case. Then what I'm doing, I need head, tail, again, function. What I need to do, I need to return a new list where I apply the function and I pass it one element, head in this case, and just to make it more performant, I do the stuff on the rest. Let's see if it solves something. I already uncommented 2 tests here. What it does? Yes, it works. It works well. But why so strange syntax here? You might ask yourself. Why we are using this dot? That's something that not sugar-coated in Elixir, and it's done on purpose. Because these functions, for example, count, reverse, map, or whatever, in the module list ops, they are named functions. We can call them by the name. When we are passing a function into as argument, then it's anonymous function to that. Even that it has the name f, it means that it's anonymous. And to run it, we need to use a special syntax. It's some peculiarity, but nothing to worry about. It just comes to you quite quickly. By the way, let's check if it also works with huge list. I believe so. Map huge list, 200 milliseconds. So it's comparable. Count, it was very simple operation. Reverse, 200 milliseconds. So filter, the next thing. What it does, filter takes a list of elements. It applies a function on each element in this list, and it returns only those elements. It returns a list, but it can be an empty list. A filter returns only elements that are truthy about this function. So let me write some code at first. We are not interested in function in the base case. Here, head, tail, function, do. By the way, here you can see that sometimes I use the short syntax with do semicolon. I use it when the function body is quite quite short. When the function body is not that short, and here I need to use if. So here what we are doing, we are invoking f, passing it head as argument. So basically, filter expects two arguments from us. It expects a list of elements, and it expects a function that it's gonna expect one argument and return a boolean like true or false. So if it's truthy return, then we are adding this element and running our code or the same function on the rest. If it's not truthy, then we are not including this in the final list. That's how it works. Let me show you how it works with enum filter, for example. So let's do 1, 10, 5, 2 list filter. Filter. Here in the filter function, I want to say element is more than 3. So this is how it works. Filter function takes a list and a function that takes one argument. Then it must return some boolean. So it must do something. You might check if data contains something that you're interested in or not, stuff like that. And eventually it returns some list. For example, if we say more than 100, it's going to return the empty list here. Next, fold. Fold, it's basically, I can be wrong here, but as far as I understand fold function, it has also two different variations. It's fold L and fold R. L means left, R means right. It tells us from which side of the list we want to fold, or in parentheses, or reduce the list. So basically, it takes a list and it takes some initial accumulator, as I showed you before with enum reduce, and it runs some function on every element. Then it reduces the list. I'm sorry for telling you maybe the same things. So let me do a little bit different here. So fold L, we are taking, again, I'm going with multiple clauses. I'm starting with basic case. I'm not interested in function. When we are done with the list, I'm just returning the accumulator. Then I need to define the general case head tail ec function. What we do, we run itself on the tail. In the accumulator, we are passing head and ec, and we are passing again the function. Here in the fold functions or reduce function, the function that we are passing, it expects two elements. If you remember, or you can just skim to the word count task exercise, you can check there that I'm passing two elements to, I'm expecting two arguments in the anonymous function that I'm passing to enum radius. So it's gonna solve it, if I'm not mistaken. Let's check the basic, and then let's check the slow one. The slow one. Yes, it works. Fold R, what it does the same as fold left, but it just starts from the opposite of the list. But it basically does the same thing, and the very, very straightforward solution here is going to be based on the function that we have already defined before. So if we want to do the fold on the list, but from the opposite direction, we can just reverse it, right? So we can reuse two functions that we have already defined before. We are using reverse, and we are using the fold left. So we are just going over over the list from the opposite direction. Let me check. Oh, I did not uncomment fold tests, but it should pass. Two more things regarding append. For the append, I was using the same approach as I used for reverse, just for performance issues. It can work with simple recursion, but on big lists we need to introduce the accumulator. So I'm going to do the same. And one more trick. Reverse. I'll tell you in a second why I'm doing this. I need the new append that starts with empty lists. Do reverse and add tail tail. It looks like some magic. Even that I'm rewriting some of my notes that I prepared. I don't believe that it works correctly, but it must work correctly. What it does here, it's a little bit harder to understand from the code, but let's check the examples. For example, when we are given two empty lists, we are receiving just empty lists, so we are skipping empty lists. The same happens empty list, non-empty list on either side. A bit interesting thing happens with 1, 2, 3, 4, 5. So as you can see, one list consists of 2 elements. The second list consists of 3 elements. Eventually, we get just one list consists of elements from both lists and in the same order as before. What happens here? Append its concatenations of the lists. I'm starting with empty list. I'm passing the left, the A list. Here, I'm do some performance optimizations. I already changing the direction of the second list. It's gonna start like 5, 4, 3. Then it goes into the accumulator. So so I'm already starting with something in my accumulator. In the very first iteration of this function, I'm going already have 5, 4, 3 in the accumulator. Then I'm taking one by one from the first list and adding them to the head of the accumulator. Eventually, that's the last instruction. Eventually, I'm reversing the full accumulator and I'm getting again the same direction. From performance point of view, it works well because as we already optimized our reverse function, it works quite fast. Oh, by the way, what? Append huge list. No, 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 no. Yes, I failed with some reversing somewhere. Reversing. Mm-hmm. 3, 4, 5. Maybe I need to do this. Yes, that was my mistake. B and A. I need to start with reversed A in the accumulator. Yeah, it's kind of typo, or maybe not. Anyway, the concatenation. Let me quickly do one thing because we are already running out of time. It's gonna work. Right. Let me check that it works. Here, what I'm doing, I'm using already predefined function that. So I'm basing my new code on the function that we defined before. That's also a very common pattern in the software engineering in general as well, and in functional programming in particular, to base your programs on the libraries and packages that consist of your language. I wanted to show you, and I wanted to wrap up our little story into Elixir world with just one small thing. It's take number task. Let me leave it even with the solution. I'm not going to go through solution, but I wanted to mention one important thing that I found myself thinking a lot about. So what I wanted to tell you, it's gonna take maybe 5 or 7 more minutes, that when I started to learn Elixir and functional programming, it was the huge shift in my mind on how I was looking at problems and how to solve them. Previously, when I was working with Ruby, JavaScript, and other languages, and in functional programming and in Elixir in very particular, because it's running and it stays on the foundation of Erlang and VM virtual machine. It's very interesting how they approach the distributed systems. So probably you have heard, maybe not, that Erlang was built by Ericsson in late 80s and 90s, and it's very active language, and it has a lot of people there and involved. And it was built for telecommunications. Why it was so important? Because they need to run telecommunications like phones and other switches for very long time without interruptions. I can tell you that almost third or maybe even half of the current internet is running and standing on Erlang and VM, because Cisco, that is building a lot of switches and routers, they use VM inside their machines. What was interesting to me that, yes, the basic syntax, the basic language, the basic library structure, that's fine, all these strings, enums, all these functional approach. But Elixir is also about something very important. It has the messaging system. So all the code in Elixir, it runs inside the processes. Processes, they are isolated from each other. They run concurrent to one another, and they communicate to each other. You do not need to mix them with operating system processes or threads, because they are very, very, very lightweight. That helps, that allows us to run millions of Erlang or BM processes on one machine, even on my laptop, for example. And they can talk to each other, so they can send messages to each other. What I was thinking about in the beginning, but how is this language supposed to only, so are we supposed to run only, to implement only some simple scripts that are taking some text input and doing some enum MapReduce magic on to it, and that's all? How do they make the system that is running? How do they store the state? And there is something that comes with the Elixir and BM. It's called OTP. It's Open Telecommunication Platform, or at least it was like that. It has some libraries like Agent or Gen Server or Supervisor, and things like that. It's already some complicated things, but I really, really wanted to mention this because these abstractions, they help us to build actual systems with Elixir. You know, at some point, I was looking at the code in Elixir that someone wrote, and then I copied it, and I started to write the similar code by myself using OTP and some basic things. And I caught myself with the thought, with some realization, oh my gosh, this is exactly how object-oriented programming is supposed to work. And I was living with that thought for a while. At some point, I was watching some old talk from Alan Kay. If you know that name, he was one of authors of Smalltalk. He worked a lot at Xerox PARC back when Apple, for example, started, and when he was doing some demos to Steve Jobs, which Steve Jobs taken for UI, but Steve Jobs did not take some other important things. And as you probably know, if you have some OOP background, that Smalltalk and Simula, the language Simula, which was just before Smalltalk, they made some foundation for OOP. But they, as you know, in OOP, you also have classes, objects, and these objects, they can send messages to each other and update their internal state. And this is how all these things work. But Alan Kay, at some point, it was even 25 years ago already. Yes, a little bit less than 25 years ago. He said in one of the emails that he wanted to try to remind everyone. Let me find that reminder. He wanted to try to remind everyone that Smalltalk is not only its syntax or classes. It's not even about classes. The big idea is messaging. So this what makes distributed systems work flawlessly, to have uptimes for years, etc. So Erlang, it was one of the first languages like that, with very very well-built actor systems and messaging system. And Elixir is also comes hand in hand with this. So this is something that I wanted to share with everyone, why I love Elixir, why, because it takes all the best from functional programming, like immutability, modules, and stuff like that. And it's also extremely simple to run big systems in it. Big systems, understandable systems for many, many people that write code for it. So I hope that you liked this stream. Please join exercism.org and solve tasks there. If you're solving them in Elixir track, then probably we'll meet each other. And if you want to find me, just open https://summercode.com or just skim to the beginning of this video to check the URL, and you can find some handlers of my social network there. So thank you very much again for watching, and see you. Have a great Saturday and weekend.